Alright, welcome back everybody. This is the start of the meat of the lectures. There's going to be a fair amount of information. There was not much information in the previous video. First thing I want to cover is what I'm going to call attachment rules, so you should write this down as well. Here is rule number 1. Carbon atoms always make 4 covalent bonds in organic molecules. So you should act like you were born with this information, that you know it in your sleep. You should also know this information like you were born with it. Hydrogen atoms always make 1 covalent bond in organic molecules. These are 2 rules that we are going to refer back to over and over again in the rest of the videos. So you should really know this and you should write this down. Here we go. So if I told you that I was working with an organic molecule and the formula of the organic molecule was CH4, that means 1 carbon atom and 4 hydrogen atoms. And I wanted you to tell me how the atoms were stuck to each other, how they were attached to each other. But you have to follow these 2 rules. Now you can pause the video and think about how they are attached to each other. And if you unpause the video, this is the only way that they can be attached to each other and not break the 2 rules that I just described. The carbon has to be in the center, the 4 hydrogens have to be on the periphery, and if you look, this carbon atom here is making 1, 2, 3, 4 covalent bonds, so it follows the first rule. And every single hydrogen is making 1 covalent bond because there's only 1 line going into each of the H's. And this is the only way that you can draw the attachments and not break these 2 rules. So the point I'm trying to make here is that these 2 rules are relatively simple, but they let you figure out how the atoms are attached in a lot of different types of organic molecules. This is our first organic molecule right there. The fancy way of saying how the atoms are attached to each other in a molecule is to say that you just described the structure of the molecule. So if I said, hey, what's the structure of CH4? What I'm asking you is, how are the atoms attached in this molecule? How are they attached to each other? This is the only correct structure for CH4. For example, if I drew this, 1 carbon, and that's 4 hydrogens as well, and I said, no, this is the structure of CH4. You could look back at these rules and you could say this is not the structure of CH4 because there is only 1, 2, or only 3 bonds going into the carbon atom, and carbon has to have 4, so just for that reason alone, this is not the correct structure for CH4. There's another rule that's also being broken, and it's being broken over here. This hydrogen has 2 lines going into it, 1 and 2, and hydrogen only makes 1 covalent bond, so that hydrogen there is breaking the rules as well. So there's 2 reasons why this is the incorrect structure for CH4. We can talk about another organic molecule. What if I said I'm working with a different organic molecule? Formula is C2H4. And I want to know what the structure is. I want to know how the atoms are attached to each other. You can pause the video and think about that. It has to have 2 carbons and 4 hydrogens, so I'm going to draw 2 carbons like this. There's 2 hydrogens, there's 4 hydrogens. And this is almost correct, but it's not correct. The reason it's not correct is this carbon here is only making 1, 2, 3 bonds, but it needs to make 4. Same is true for this carbon over here. It's only making 1, 2, 3 bonds. The way to fix this is to do this. Put a double covalent bond between the 2 carbons in the middle, and now every carbon in that molecule has 4 covalent bonds. 1, 2, 3, 4. Same is true with the other carbon, and if you look at the hydrogens, they are all only making 1 covalent bond, and so this is the only correct structure for C2H4. Again, these 2 rules are pretty simple, but they are powerful in that they let you figure out how the atoms are attached, or they let you figure out the structure of many different organic molecules. Not all of them, but many of them. So you'll see you can have double covalent bonds in your organic molecules. Third organic molecule. I tell you that I'm working with a molecule and the formula is C2H2 and I want to know what the structure is. You can pause the video and think about that. This sucker has 2 carbons and 2 hydrogens, so I'll try my trick again. I'll give it a double bond this time. Oop, 2 hydrogens, right? Screwed that up. There, 2 carbons, 2 hydrogens. If you look again, we are breaking a rule. This carbon here has only 1, 2, 3 covalent bonds, but it needs 4. Same thing is true for the other carbon. So the only way to fix this is to put a triple covalent bond in between the carbon atoms. Now this carbon over here has 1, 2, 3, 4 covalent bonds. So does the other carbon on the other side. And if you look at the hydrogens, there's only one solid line going into them, which means they're both making 1 covalent bond. So this is the only way that we can draw C2H2 and not break these 2 rules above. Everyone good? I can't hear you. Alright, I'll take your word that you're good. Everybody's nodding. One thing I want to point out, and I'm going to use this as an example. I said the structure of CH4 is this a little while ago, and that is correct. But I am drawing on a flat surface, and I don't want you to believe, I don't want to mislead you into thinking that this is a flat molecule. In real life, this molecule has a 3-dimensional shape. In fact, it's shaped like a pyramid, like this over here. The carbon is in the center, and the hydrogens are like the corners of a pyramid. There's a reason for that. We might talk a little bit about it later in the course. There's a fancy name for this pyramid shape. You say that the molecule has a tetrahedral shape. You do not need to know this. But I do want you to know that these molecules have a 3-dimensional shape. That is going to become important in not this week's videos, but in videos coming up in future weeks. Okay, that's it for this video. I will see you in the next one. Main takeaway here is these 2 rules and sort of understanding what structure means and how to use these 2 rules. So I will see you in the next video.
Whoa, oh, I'm a rebel just for kicks, man. I've been feeling it since 1966, man. I keep my hands to myself.